So this is our next chapter in the unit trigonometry, solution of right triangles. In this kind of problems in the current topic, we will be given a right angle triangle and uh, maybe one of its angle and one of its sides. You have to find the remaining sides, length of the remaining sides. So for solving the questions, we will take the help of trigonometry and we can easily find out the measures of the missing sides or angles. Okay, so let me show you how the questions are done. Also in some of the questions figures are given, diagrams are given, and in some questions the figures are not given. Okay, so I will also teach you how to draw the figure after reading the question. Okay, so let's begin. In a triangle ABC, right angled at B, so I have drawn this triangle ABC, right angled at B. Side BC is 20 centimeter and angle A is 30 degree. Find the length of AB. Now with respect to angle A, if angle A is our angle of reference, what is BC and AB with respect to angle A? BC is the opposite side, AB is the adjacent side. So what is the ratio of opposite and adjacent? So the ratio which we will use is SOHCAHTOA. SOHCAHTOA. So the ratio of opposite and adjacent which we will use is tan. Tan of angle A is opposite upon adjacent, or tan 30 is equal to opposite, which is BC, upon adjacent, which is AB. Tan 30 is 1 by root 3 is equal to BC, which is 20, and AB, which is not known. So AB will become 20 times root 3. 20 times 1.732. So AB will be 34.64 centimeter. That's it. So this is very simple. The first problem which you saw, very easy. You just have to apply trigonometry and find the missing sides of a triangle. That is this chapter all about. Okay, let's go to the next question. Without calculating other, what other? Let me check the question once. Without calculating other lengths, use tables to find the angles x and y. Okay, so you have to use tables, the trigonometric table of standard angles to find x and y. So they are saying that don't find the other sides, other lengths basically. So we are not to use Pythagoras theorem, right? So we have to find x and y. Now let us first talk about x. With respect to x, this side is the hypotenuse and this side is opposite. Now if it is confusing, let me name it A, B, C, and this is D. So I can write it as in triangle ABC, angle BAC is 90 degree. Angle BAC is 90 degree. Angle ABC is X, right? BC is 10 and AC is 5. We have to find the value of X. So BC is the hypotenuse and AC is the opposite to angle X. So which trigonometric ratio relates hypotenuse and opposite? Sine, SOHCAHTOA, so SOH. So sine of angle X is opposite upon hypotenuse, which is equal to, opposite is AC upon BC. Okay, so sine of angle X is AC, that is 5 upon BC, which is 10. So sine of angle X is 1 by 2, right? So sine of angle X is equal to, in the place of 1 by 2, can I write sine of 30? Yes, sine 30 is 1 by 2, right? So we are using trigonometric tables over here. Therefore, X is equal to 30 degree. So that's how you find the value of X. Now let's find the value of Y. So in triangle BCD, angle DBC is 90. Angle BCD is Y. BC is equal to BD is equal to 10. BC is equal to BD is equal to 10. So you can say that with respect to angle Y, BD and BC are opposite and adjacent. And which trigonometric ratio relates opposite with adjacent? It is tan. So tan Y is equal to opposite upon adjacent, which is BD upon BC. So tan Y is equal to 10 upon 10, because BD and BC both are 10. So this cuts and gives 1. So tan Y is equal to 1, and therefore Y is equal to 45 degree. Y is 45 because tan 45 is 1. Right? Let's go to the next question. Use the information given in adjoining figure to find the length BD. Okay, so we have to find the length BD, the angle C or theta, and length BC. Okay, now we can see two right angle triangles over here, ABD and ADC. Okay, great. So in triangle ABD, we know that angle ABD is 45 degree. So tan of 45, why I am taking tan, I'll tell you, is equal to opposite upon adjacent. Tan 45 is 1. Opposite of 45 degree is AD and adjacent is BD. So we can say that therefore AD is equal to BD. AD is equal to BD. Okay, therefore we can say that BD is equal to 10 centimeter. So why we used tan? We used tan because we had to get the relationship between opposite of angle 45 and adjacent to angle 45, that is AD and BD. That's how we found BD. That's why we used tan. So which trigonometric ratio to use in which situation, that skill you have to learn. Now in the other triangle, in triangle ADC, which is also a right angle triangle, we have to find theta. We have to find theta and then find the relationship between AD and AC. So with respect to theta, AD is opposite and AC is hypotenuse. Now which trigonometric ratio relates opposite and hypotenuse? Opposite and hypotenuse is related by sine. So in triangle ADC, sine of angle theta is equal to opposite upon hypotenuse. So sine theta is equal to AD upon AC. So sine theta is equal to AD is 10 centimeter and AC is 20 centimeter, which is 1 by 2. And therefore theta becomes 30 degree because sine 30 is 1 by 2. So that's our second answer. Theta is 30 degree. Now since we have found theta, we can easily find CD. Why we need to find CD? Because they are asking about the length of BC. So in triangle ADC again, tan theta is equal to opposite upon adjacent. That is tan 30 degree is equal to opposite, which is AD, upon adjacent, which is DC. Tan 30 is 1 by root 3, which is equal to AD, which is 10, upon DC, which is not known. So DC is equal to 10 root 3. So DC is equal to 10 times 1.732, that is 17.32 centimeter. Okay, so we found DC. Now what is BC? BC is BD plus DC. BD we already know 10 and DC 17.32. So it is 27.32 centimeters. Yes, so this is question number 3. All correct answers. Let's go to question number 4. Okay, so from the adjoining figure, we have to find the length of AC. This is a very good question. Now, for finding the length of AC, we have to take, let AC be X. Let AC be X units. I'm sorry, it is meters. So let me take it as meters. Let AC be X meters. Okay. So in triangle ADC, tan 45 is equal to opposite upon adjacent. Right? Tan 45 is 1, opposite is AC and adjacent is CD. So 1 is equal to AC is X upon CD, and therefore CD is equal to X meters. So we found that CD is also X meters. Okay. Now we take the bigger triangle, that is in triangle ABC. In triangle ABC. Again, in this bigger triangle ABC, we will compare the opposite and the adjacent. That is tan. Tan of angle 30 is opposite upon adjacent, which is AC upon BC, because we are taking the bigger triangle. And tan 30 is 1 by root 3. AC is X and BC is 40 plus X, BD plus DC, which is 40 plus X. Let's cross multiply and simplify this. So 40 plus X is equal to root 3 times X. So 40 is equal to root 3x minus X. So 40 is equal to X bracket root 3 minus 1. So 40 upon root 3 minus 1 is equal to X. We can simplify this by rationalizing the denominator. 40 upon root 3 minus 1 times root 3 plus 1 upon root 3 plus 1. Okay, so we get 40 bracket root 3 plus 1 the whole upon 2. Root 3 square is 3 minus 1 is 2. So we get x is equal to 20 root 3 plus 20. Now 20 root 3 is 20 times root 3. That is 20 multiplied by 1.732. That is 34.64 plus 20, which is 54.64 meters. That is the value of x, which is AC. We had to find AC. 54.64 meter. I hope you understand the whole concept behind this chapter. There is nothing new they are teaching. They're just giving you triangles, length of some sides, length of some other sides are missing. They are giving you angles. You have to use trigonometry, find the relations, ratios of those sides which are missing and which are given. Use the standard values of the trigonometric ratios of the standard angles and solve the questions. So all the angles which you see 35, 40, 30, 45, in this also 45, or the missing angles also are 30, 45, 60 and so on. Okay, let's go to the next question. This is rhombus. So in a rhombus ABCD, length of each side is 10 centimeter. Okay, and angle A is 60 degree. Find the length of its diagonals. Okay, so this is a good question. So see, we will use a property of rhombus. In rhombus, the diagonals bisect the diagonals bisect each other at right angles. Therefore, AC is perpendicular to BD, that is angle AOB is 90 degree. Also, AO is equal to OC and BO is equal to OD. So in rhombus, the diagonals bisect each other at right angles. Also, in rhombus, diagonals bisect the angles at the vertex. So what they are saying that angle A is 60 degree. This angle A is bisected by the diagonal AC. So therefore angle OAB will be equal to half of angle A, which is half of 60, which is 30 degree. So this small angle is 30 degree. That's what we mean to say. Okay, great. So in triangle AOB, in which angle AOB is 90 degree, we have to relate this side AB with, which is the hypotenuse. Let me write angle AOB is equal to 90 degree. AB is equal to 10 centimeter, which is the hypotenuse. AO is missing and OB is missing. AO and OB are missing. Okay, so if we want to find, let's say, OB, how can we find OB? OB is the opposite side of 30 degree, and AB is the hypotenuse. So which is the relation between hypotenuse and opposite? So sine 30 degree is equal to opposite upon hypotenuse. What is opposite of 30 degree? OB. And what is the hypotenuse? AB. Sine 30 is 1 by 2. OB is not known. AB is 10. That means OB is equal to 10 by 2, which is 5 centimeter. Now we just got OB, and OB is equal to OD. So OD will also be 5 centimeter, which gives us the length of diagonal BD. Okay, so we can write therefore BD is equal to 2 times OB, which is 2 times 5, which is 10 centimeter. Okay, so now what we are going to do is we are going to find AO. AO is the adjacent side, and we know the hypotenuse, which is 10. So cos 30 degree is equal to adjacent upon hypotenuse. Cos 30 is root 3 by 2. Adjacent is AO. Hypotenuse is AB. So root 3 by 2 is AO, which is not known, and AB, which is 10. So AO is equal to root 3 times 10 by 2. So AO is equal to 5 root 3. AO is equal to 5 root 3 centimeter. Now if you multiply root 3 with 5, you will get the exact value of AO. But don't do that as of now. So therefore we can say that AC, which is the other diagonal, is 2 times AO, because diagonals bisect each other. So 2 times 5 root 3, which is 10 root 3 centimeter, which is 10 times 1.732, which is 17.32 centimeter. That is AC. So we have got AC and BD. BD is 10 centimeter, AC is 17.32 centimeter. Nice question. Let's go to the next question. And that's a diagram for it. In the given figure, a rocket is fired vertically upward from its launching pad P. So this is the launching pad from which the rocket is fired vertically upward in the direction PA. It first rises 40 km vertically upward and then 40 km at 60 degree to the vertical PA. So पहले वो 40 किलोमीटर ऊपर जाता है और फिर वर्टिकल के साथ 60 डिग्री का एंगल बना के 40 किलोमीटर टूवर्ड्स द राइट जाता है. PA represents the first stage of the journey and AB the second. C is the point vertically below B. B ये उसकी फाइनल पोजीशन है रॉकेट की, उसके एग्जैक्टली नीचे एक पॉइंट C है ग्राउंड के ऊपर. Calculate the height of the rocket when it is at point B. Okay, so we have to find BC and the horizontal distance of point C from point P. Great. So for this we have to do one small construction. We have to draw AD parallel to the ground. So I will write over here, draw AD parallel to PC. Now since angle C is equal to 90 degree, therefore angle ADB is also 90 degree. Why? Corresponding angles, right? So this angle is 90 degree because AD is parallel to PC. We have constructed. So since angle C is 90, angle D is also 90. Correct? Also, AP is equal to DC, opposite sides of rectangle. AP is equal to DC. See, since this is also 90, this is also 90, this has to be 90. So this becomes a rectangle. So AP is equal to DC, and therefore DC is 40 kilometer. DC is 40 kilometer. Okay, so we know that this is also 40. See, what we have to find is BC and PC. BC and PC. Okay, so consider triangle ADB. In triangle ADB, angle ADB is equal to 90 degree. Angle ADB is equal to 90 degree. Also, angle BAD is equal to angle BAD is equal to 90 minus 60. I'll tell you why. See, this whole angle will be 90, right? Because AP is parallel to BC. And this vertical angle is 60. So how much this angle becomes? This angle becomes 30 degree. This angle BAD becomes 30 degree. Correct? So in triangle ADB, tan 30 wait, not tan, because we have been given the hypotenuse and we have to find the opposite and the adjacent. So first we are going to use sine. Sine 30 is equal to opposite upon hypotenuse. Sine 30 is 1 by 2. Opposite is BD. Hypotenuse is AB. BD we don't know. AB is 40. So 40 by 2 is equal to BD. So BD is equal to 20 kilometer. BD is 20 kilometer. So we just found our first answer, which is the height of the rocket when it is at point B. Therefore, BC is equal to BD plus DC. That is 20 plus 40, which is 60 kilometer. Height of the rocket when it is at point B is 60 kilometer. The second thing which we have to find is PC. We can find PC by finding AD, because AD and PC are equal, because ADCP is a rectangle. Okay, let's find AD. So first we took sine. Now we can take tan. Okay, so tan of 30 degree is equal to opposite upon adjacent, which is 1 by root 3. Opposite is BD. Adjacent is AD. So 1 by root 3 is equal to BD is 20. AD we do not know. So AD is equal to 20 root 3, which is 20 times 1.732, which is 34.64 kilometer. So therefore AD is equal to CP, I think. Yeah, CP. 34.64 kilometer. Interesting question. This is the whole solution with the figure. Great. Let's go to the next question. Yeah, so this was question number 4. Hey, no, this was question number 5. So this should be question number 6. And this should be question number 7. In the given figure, AB is perpendicular to BC, DC is perpendicular to BC, BD is perpendicular to AC, and angle D is 30 degree and DC is 60 root 3 meter. Find the length of AB. Okay, so in triangle BDC, angle BDC is equal to 30 degree, angle DCB is equal to 90 degree. Therefore, we can find this third angle. Angle DBC is equal to 180 minus 90 plus 30. That is 180 minus 120, which is 60. So this is 60 degree. We have to find the length of AB. Okay. For finding the length of AB, we should know at least one angle of triangle ABC. In triangle ABC, we know that angle ABC is 90 degree. Okay. So we found angle DBC to be 60 degree. Now in triangle OBC, please observe where is triangle OBC. It is over here. This is triangle OBC. So in triangle OBC, angle OBC plus angle OCB plus angle BOC is equal to 180 degree, angle sum property. So angle OBC is 60 degree plus angle OCB we do not know, plus angle BOC is 90 degree. Angle BOC is 90 because AC is perpendicular to BD, is equal to 180. So angle OCB plus 150 is equal to 180. So angle OCB is equal to 180 minus 150. So angle OCB is equal to 30 degree. So we found angle OCB to be 30 degree. Okay, let me just mention that in the figure because that is what is important. That is angle OCB or angle ACB, 30 degree. Great. Now we have to find the length of AB. But for that we need at least one length in triangle ABC. So let's find the length of BC first from triangle DBC. So in triangle DBC, tan 30 degree is equal to opposite upon adjacent. Tan 30 is 1 by root 3. Opposite of 30 degree is BC and adjacent is DC. So 1 by root 3 is equal to BC is not known and DC is 60 root 3. So BC is equal to 60 root 3 by root 3. So BC equals 60 meters. BC equals 60 meters. Now we can consider triangle ABC. In triangle ABC, if you see triangle ABC, you know the angle ACB, which is 30 degree. You know the adjacent side, which is 60, and you have to find the opposite, which is AB. So tan of angle 30 is equal to opposite upon adjacent. Again 1 by root 3 is equal to opposite, which is AB, upon adjacent, which is BC. So 1 by root 3 is equal to AB, which we don't know, and BC, which is 60. So AB is equal to 60 by root 3. Now let us simplify this. So AB is equal to 60 by root 3 times root 3 by root 3, rationalizing. So we get 60 root 3 by 3, which is 20 root 3, which is 34.64 meters. That is the length of AB. 20 root 3 or 34.64. Okay, so the question becomes complicated when there are multiple triangles in single question and you have to find the length of missing triangles. Okay, so the next figure, the last question actually. ABCD is a trapezium in which angle A and angle D both are 90 degree and CD and AB are parallel to each other. Angle C is 120 degree. Let me mark it over here. Okay. DC is 28, BC is 40. Okay. Find AB, AD and the area of trapezium. AB, AD and the area of trapezium. Okay. In this you need to do a construction. Draw CE parallel to AD. CE parallel to AD, so it will look like this. This is CE parallel to AD. Therefore, angle CEB will be equal to angle DAE. Corresponding angles. Angle CEB is equal to angle DAE, corresponding angles. Therefore, angle CEB is equal to 90 degree. Angle CEB is equal to 90 degree. Okay. Also, CD is parallel to AE, sorry, AB or AE. It is given. Therefore, you can say that angle CEA is equal to angle DCE, co-interior angles. Okay. Let me write it this way. I cannot write it directly equal. See, CEB is 90. So CEA has to be 90. Let me write that first. So some steps are very much necessary. You cannot skip them. So angle CEB is 90. Therefore, angle CEB plus angle CEA is equal to 180 degree, linear pair. Okay. So 90 plus angle CEA is equal to 180 degree. Therefore, angle CEA is equal to 180 minus 90, which is 90 degree. Angle CEA is 180 minus 90, which is 90 degree. Okay. Now, angle CEA plus angle DCE is equal to 180 degree. That means this angle and this DCE is 180 degree. Why? Because they are co-interior angles between two parallel lines. AE and CD. AE and CD are parallel because it's given. So the co-interior angles will be supplementary. So CEA is 90 plus angle DCE is 180 and angle DCE becomes 180 minus 90, which is 90 degree. So angle DCA is 90 degree. We have proved it. Okay, now angle DCB is 120 degree. Angle DCB is equal to, now what is angle DCB? Angle DCB is the sum of DCE plus BCE. Angle DCE is 90 degree plus okay, DCB is 120 degree and we do not know what is angle BCE. So angle BCE is equal to 120 minus 90, which is 30 degree. So this is, just a moment, let me erase this part. Yeah, so this is 90 and this is 30. So the sum of angle DCB is 120, which is given in the question. So we found angle BCE to be 30 degree. Now we can easily find two sides in triangle BCE. One is BE and the other is CE. BE and CE. Okay, let's find BE and CE in triangle BCE. In triangle BCE, in triangle BCE, tan 30 degree is equal to opposite upon adjacent. So tan 30 is 1 by root 3. Opposite of 30 degree angle is BE. I think we should use sine because we do not know adjacent, neither we know opposite. So let me take sine over here. Sine 30. We know the hypotenuse. So sine 30 is 1 by 2, which is opposite upon hypotenuse. Opposite of angle 30 is BE and hypotenuse is BC. So BE upon BC. So 1 by 2 equals BE, we do not know, BC is 40. BE upon 40. So therefore BE is equal to 40 by 2, which is 20 centimeter. BE is equal to 40 by 2, which is 20 centimeter. Okay, so we found out BE 20 centimeter. Now we can find out CE. Okay, so for finding CE, we can use tan. Therefore, tan of 30 degree is equal to opposite upon adjacent. Tan is 1 by root 3. Opposite is BE and adjacent is CE. So 1 by root 3 is equal to BE, which is 20, CE, which is not known. CE will become 20 root 3, which is 20 times 1.732, which is 34.64 centimeter. This is CE. Okay, so we found CE to be 34.64. Okay, great. So now we will be able to find the missing sides, right? We had to find AB. What is AB? AB is AE plus BE. What is AE? AE is equal to CD because ADCE is a rectangle. So AE is 28. BE. BE we just find out 20. So AB is 48 centimeter. That's the first answer. Second, you had to find AD. Now AD is equal to CE, opposite sides of rectangle. So therefore AD equals CE, we just found 34.64 centimeter. So we found AD. Okay, and now we want to find the area of trapezium. So area of trapezium ABCD is half times sum of parallel sides multiplied by h, that is the distance between them. Okay, so what are the parallel sides? Parallel sides are AB and CD. And the distance between them is AD. So half times AB is, we found AB 48 and CD is 28. 48 plus 28 times 34.64. Okay. 48 plus 20 is 68 plus 8 is 76. 76 by 2 times 34.64. So that is 38. 76 by 2 is 38. Times 34.64. So let's check the area. 760 root 3. So they are getting the area in 760. In terms of root 3, let me just calculate and tell you the exact area in centimeter square. Okay, so it comes out to be 1316.32 centimeter square. So these were all the solved examples of chapter 24. Very simple chapter, solutions of right triangles. There is only one exercise, so after watching this video you have to do that exercise, and I will soon send the video of the last chapter of the unit trigonometry, that is chapter 25. Till then you please complete all the exercises of chapter 22, 23 and 24. Okay, see you in the next video. Bye bye.